Today what we're going to do is we're now starting into actually solving addition, subtraction, and then we'll do multiplication, division, and eventually we'll get to two-step operations maybe, depending on how much quicker we can go. But we've done enough time on actually writing them, especially because we spent so much time on writing expressions. The real key is realize when we add equations, literally all you're doing is adding the equal sign. And that's really focused around the is and are, or whatever is telling you that those two pieces are separated, okay? So now let's talk about actually solving them. In order to solve one-step equations, we'll give you guys a little method for doing it in a short bit here. But we need to understand a few properties, and then we'll work through some examples. Now, our first property we're going to talk about is the subtraction property of equality. So, in the subtraction property of equality, what it's basically saying is, if you subtract the same number from each side of an equation, the two sides remain
the same.
Equal. Okay? So, subtraction property of equality. All we're saying is, if I have something like this, 20 plus 10 equals 30, is everybody okay with that?
I think that's right.
Okay? If I subtract the same number from both sides of my equation, what is 10 minus 10? 0. 20 plus 0 is 20. 30 minus 10 is, we have the same thing. It's still equal. Does that make sense? Why would we need that? Great question. The reason we need that is now that we're getting to solving equations, we're going to have variables, things we don't know. So, for example, what if I had a minus 14 equals 24? I'm sorry, a plus 14 equals 24. Okay? A plus 14 equals 24. We're actually going to use the subtraction property of equality in order to solve this. We're going to take away the same number on both sides. We're going to take 14 away. So if I take 14 minus 14, what do I get? 0. So technically what we have on this side is a plus 0 equals 24 minus 14 is 10. Now, previously we've discussed a property of mathematics that says a plus 0 is just a. What property was that?
What? A plus 0 is identity property of one. The identity property of one. Zero. The identity property of zero. Identity. No, the identity property.
I'll give you a clue. What operation?
The identity property of addition.
Of subtraction.
What property?
Addition.
What operation?
Addition.
Addition.
Subtraction. Identity property of addition. Identity property of addition. Identity zero property of addition.
You got all the words in the wrong order.
Identity variable. Property of
Identity property of addition. Identity property of zero.
Okay. Here, let me solve it for you guys.
A plus 0 is away. Addition property identity.
Additive. Identity.
Property of 0.
There you go. Good job, Lydia. Property of 0. Additive identity property of 0 says, if I add 0 to any number, I still get that number. Meaning on this side of my equation, I now have a plus 0, so what does that equal? A. So I can get rid of that and just say a equals 10, and now I have my solution. So just to check, and here's a nice thing about these properties and this type of work, you can actually guarantee yourselves an A+. Because all you have to do is check. I substitute my value back into my equation. 10 plus 14 equals 24. Does 24 equal 24?
Yes.
Check.
24 is.
Again, if we have a true statement, then I have solved my problem correctly. If I were to add it up and figure out it didn't work out, then I would know I need to go back and figure out where I made a math error. What's confusing you?
The fact where you pulled out 2 14s out of nowhere.
I didn't pull 2 14s out, and we'll get to that in just a second. So hold your thought, and we'll talk about it in a minute. Solo?
What's 3 times 9?
15.
You not know that.
Okay, the other one that we're going to be using today, excuse me,
Yes.
is our addition property of equality, which says if I add the same number to each side of the equation, the two sides remain equal. Okay? So Ms. McShann did not like my earlier example, so let me change up my example a little bit. If I have 50 minus 15 equals 35. What would be the opposite of subtracting 15? So if I add 15 to both sides, 15 minus 15 gets me 15 minus 15, 0. So that's just going to be 50. 35 and 15 is? Does 50 equal 50? So even though I added 15 to both sides, did my actual math change? No, they stayed equal. Okay? Now let's look at algebra. What if I do an algebra example? Let's say C minus 14 equals 14. What would be the opposite of subtracting 14? Adding 14. So I'm going to add 14, again, to both sides of my equation. And that's one of the keys on both of these properties. 14 minus 14 is 0, so I just have C. 14 and 14 is 28. So we verify our answer. 28 minus 14 equals 14. 28 minus 14 is 14. That's 14 equals 14. Check. Okay, so now that we've got those two, now let's talk a little bit further. To actually solve equations, what we're really talking about, we can use inverse operations to solve equations. Inverse operations basically undo each other. For example, to solve an addition equation, I'm going to use subtraction, the inverse operation, and vice versa. If I have a subtraction equation, I'm going to use addition. Now, to help you visualize what's happening, we're going to go through a little process here. We're going to use a scale. Who knows what's important about a scale? If my scale is level, what does that mean?
Devin, you
Solo.
ran out of shit. What?
What was your answer?
So if the scale is level, that means the equal weights.
Equal weights on both sides. Everybody good with that? Okay. So if a scale is a balance, it means it has equal amounts on both sides, right? So we can think of the center of our scale. If I'm doing this mathematically with what we're talking about, what do you think that fulcrum, that middle piece would be? That's our equal sign. So if we think of that as being our equal sign, that's going to help us understand what's going on. So we're going to draw the equal sign inside of the fulcrum. Okay? We're now going to draw a dotted line through the middle of the fulcrum. Why? Because this is how we're dividing up our scale into the two pieces that are equal. On the scale, we're going to do this problem. X plus 6 equals 10. Okay? So x plus 6 and 10. So if I wanted to find out what x was, and I have this two pieces over here, I have this x and this 6, what would I do on this side to get the x by itself? I would just take the 6 off, right? So on this side, I'm going to take the 6 off. But if I only take the 6 off of one side of my scale, what's going to happen? It's going to go like this, right? So what do I need to do on this side to keep it balanced? Does that make sense? So if I take 6 off both sides, would my scale still be equal? Why not?
Because if you take it off the 10 it'd be 4, but you don't know x, so it could be like 3 or like 5.
Schrodinger's cat. You don't know what x is until...
Good. But before you go there, Kaden, think about this. Is my scale equal right here at x plus 6 and 10? If it's flat, is my scale equal? It is, right? Now, if I take that same 6 off of both sides, is it still going to be equal? If I take the same amount off of both sides, is the scale going to change?
The scale started equal. No. Okay, Kaden. The scale started equal. You take the same amount on both sides, it's going to stay equal.
It won't. It'll stay equal. So here's the part that we're getting to. So I have 6, and I've taken 6 off. Or we just moved it all the way down there. Either one. Ignore that. I have the 6. I've taken that 6 off, right? What is left on this side of my scale, Kaden? What's left on this side of my scale? X. What's left on this side of my scale after I took 6 off? 4. So I now know what was that x? The x equaled 4. So let's just check this. Here's our work. Here's how we do this mathematically. X plus 6 equals 10. I'm going to take that same amount off of both sides. I'm going to take 6 away from both. Which property did we just talk about that says I can do that as long as I do it to both sides?
The identity property of 0.
No, that was a different one.
The addition.
No. You guys are thinking the wrong one.
Identity property.
Subtract from both sides.
Subtraction identity property of 0.
Good. Our subtraction property of equality, guys. Our subtraction property of equality said, if I take the same away from both sides, my equation stays equal. That's the subtraction property of equality. Now the additive identity property of 0 came at this point, because right now I technically have x plus 0 equals 4, right? Here's where the additive identity property of 0 came in. Instead of a plus 0, or x plus 0, I can just say this is x. That's where additive identity property of 0 came in. Make sense? Now we can check it. So I now take my value and I substitute it in, and I just say 4 plus 6 equals 10. 4 plus 6 is 10. Does 10 equal 10? Check. I got the right answer. David? Because that wouldn't be the same. There's a huge difference between equals and subtracting.
I think I see what it means, but it's still wrong. I think you got it wrong.
Okay, David, let me help you here. Okay, guys, I'm going to give you 4 steps. Okay? Here are the 4 steps to success in today's problems. Step 1. Circle your variable. Step 2. Draw a line through the equal sign. David, you should be writing this down.
And you need to fix your math.
Step 3. Find the number with the variable. And step 4, this is the longest of the 4 of the steps. Not the hardest, it's actually relatively easy. Do the opposite operation with that number on both sides. And that's where our subtraction property of equality and addition property of equality come in. Okay, I will be straight up with you guys. Do the circling and the line really matter? No. However, the first 3 years I taught this, my diagram or my algorithm was just steps 3 and 4, and I still had tons of people failing the tests. And it took me a while to figure it out. And the problem was, since this is really your first introduction into the equations, students weren't understanding which number they needed to focus on. So that's really the whole purpose of the wall and the circling of the variable. Circling the variable to help you understand what number you're working with, the wall to make sure you do it on both sides. Okay? So if you'll follow these 4 steps today, your problems really should not be too terribly hard. That's okay, you watch the video, David. That's why we're taping. Well, that's your choice. Bad decisions have bad consequences. Okay, we're going to do a couple more using the scale before we get rid of it. Put your equal sign in here right away. Draw your wall. On this side is our x plus 4. On this side is our 10. So if I circle my variable, what number is with it?
4.
What's the operation? So the opposite would be?
Subtraction.
So I'm taking 4 away from both sides. Those have gone away. So on this side I just have x. 10 minus 4 is? Caden, are you seeing that on the scale level? Okay, so now let's look at it on the math level. X plus 4 equals 10. Here's our step. Circle our variable, draw our line. Should make it very easy. I think even David at this point can see the number that is with my variable, right, David? What number is on the same side of the wall as the variable? 4. What's the operation?
Addition.
So the opposite would be? Subtract. Do that to both sides. Those go away. X equals 10 minus 4 is 6. Here's one of the best things about equations. You guys can guarantee yourself an A+. Even key. If you were to actually start paying attention. Okay? Because all I have to do is substitute this value back into my equation. So I say 6 plus 4 equals 10. 10 equals 10. Unless I make a math error, I just guaranteed myself that I got the correct answer. And it's that easy. That's showing that you have the true solution. Basically, we're making a true statement. The check shows I made a true statement. Okay, again, it doesn't just happen with addition. I can also do this with subtraction. X minus 3 and 6. So what would be the opposite of subtracting 3? Adding 3. So I'm going to add 3 to both sides of my scale. These are still going away. X equals 6 plus 3 is 9. So mathematically, what does that look like? X minus 3 equals 6. Circle our variable, draw our wall. What's the opposite of subtracting 3? Anything I do to one side, I must do to the other side. Additive property, addition property of equality. Those have gone away. So I have x. 6 plus 3 is 9. We can do our check. Substitute the 9 in for our x. Make sure that it is actually equal. Check. 6 equals 6. Check.
I was
not writing. It's really not. Okay, here's another reason why our wall is important. Sometimes our variable is not first. But guess what? The process is still exactly the same. So instead of adding 2, I would subtract 2. Anything I do to one side of my scale, I must do to the other side. 2 minus 2 goes to 0, so I now have x. 7 minus 2 is 5. Mathematically, how do we do this? 2 plus x equals 7. Here's our variable, draw our wall. What number is with our variable? The operation is addition, so the opposite would be subtraction. So I'm going to subtract 2 from both sides. 2's go away because that becomes 0. 7 minus 2 is 5. We can do our check. That's terrible on your scissors, right? Scissors and cutting metal is not a good idea. So 2 plus 5 is 7. 7 equals 7. Check. We got the right answer. Yes, David? I'm taking the number that is with my variable and I'm getting rid of it. It's technically what I'm doing.
Mr. Moore, I found an easier way to do this.
I know, Solo. But guess what, Solo? Your easier way to do this is exactly why our next page is set up exactly like it is.
Okay.
Because there are several of you who are going to be like, Mr. Moore, I don't have to do all these steps. I can do this in my head. So guess what we did?
Decimal.
Decimal.
Oh, even more. You'll see when we get to the next page.
Guys, sit down and list for your recording.
What is the opposite of subtracting 3? So I'm going to add 3 to both sides. Those 3's have now gone away. X equals 2 plus 3 is 5.
Right. Put your chair down.
X minus 3 equals 2. Here's my variable. There's my wall. The number with my variable is the 3. The operation is subtraction, so the opposite will be addition, but I must do it to both sides. Addition property of equality. I can add that same number to both sides and keep my equation equal. The 3's have now gone away. This is just x because of the additive identity property of 0. And we now know that x is 5. We can do our check. I substitute 5 in for my x. 5 minus 3 equals 2. 2 equals 2. Check. That is called your check, David. That's what allows you to get an A+ in math. Well, that plus doing your homework, but
Do I get an A+ in that?
do you do all your homework?
Get me an A+.
Okay, our next one. Now let's look at it in a word problem. Ruben and Tariq have 245 and 5/10 downloaded minutes of music. If Ruben has 132 minutes, how many belong to Tariq? So there's our question. Write and solve an addition equation. Ooh, there's a key. So there's a direction to determine how many minutes belong to Tariq. What property did you use? So there's another question on there at the end, isn't there? Now, here's why this is so important. Because if I just write any equation, am I guaranteed to be right?
No.
Why not?
Well, wait, if you write any equation,
Uh-huh. Because I know there's a whole bunch of you that are going to say, okay, 245 and 5/10 minus 132, right?
no.
I bet if I looked at your homework, there are many of you who did that instead of actually following what was written.
It's 245.5 equals 132.7.
Why?
It says do an addition equation.
Because it says that I have to do an addition equation. So what's our first step in doing an equation? Let me give a caveat in doing an algebraic equation.
Define your variable.
Define my variable. So what is my variable in this case?
X.
X is what?
X minutes of music for Tariq has.
Good. So the number of minutes of music for Tariq. Is everybody okay with that? Okay, so our next step is, now let's do our translation. It says we need an addition equation, right? So it says 245 and 5/10 is equals 132 plus x. So have we now written an addition equation?
Yes.
Yes. So now we're ready for our next step, which is solving it. So solving, I circle my variable, draw my line. What's the opposite of adding 132? Anything I do to one side of my equation, I must do to the other side of my equation. Those have now gone away. I just have x on this side. How do I subtract decimals? What's the key rule?
Line it up.
Line up my decimal place. If I don't see my decimal place, where is it?
At the rightmost part.
At the far right. Okay? So it means that my decimal is actually right there. So to line up my decimals, I can add a 0. If you understand that's blank, you can do that. I don't care. 5 and 0 is 5. Decimal comes straight down. 5 minus 2 is 3. 4 minus 3 is 1. 2 minus 1 is 1. So my x equals 113 and 5/10. Does it matter that the variable was on the right-hand side? No, it doesn't. Still solves the exact same way. Okay? So, are we not done?
No, we are not.
We're not. What
property did we use? The second part of the question.
Good. Second part of the question is, what property did we use? What property did we use?
Subtraction property of equality.
Nice. It was the inverse operation, but it asked specifically for the property. Inverse operation is not a property. Subtraction property of equality is what we used. Now technically we also used what? Additive identity property of 0. But really to solve it, we used the subtraction property of equality. So now are we done?
Yes. Yeah, we are done. I am 100% sure we are done.
100%? So you understand how to solve word problems. What my answer should look like.
Oh, wait, we have to put it in a full sentence. So you are 100% correct.
So your 100% correct was wrong, because we don't have a full sentence. So Tariq had 113 and 5/10 minutes. Again, using your labels is essential of music. Now are we done?
Yeah.
No? Why not, David?
You're done. Clear.
Now, if you wanted to be 100% positive, you can check, substitute your values. So substitute my values, 132 plus 113 and 5/10 equals 245 and 5/10. 245 and 5/10. Add these two together, I have to line up my, whoa, that was fun. I was writing 132 above it, and it did all kinds of funky things. So line up my decimals, that gives me 5/10. 5, 3 and 1 is 4, 1 and 1 is 2, 245 and 5/10. Yes, so we do have a check. Questions? No, you can't do your homework because we have what we'll call the solo page. Because solo just wanted to do all these mentally. Because initially we did do homework. But we changed it and decided to do this in class and add the homework instead.
I told you to say homework.
Nope. It's only homework if you don't finish it in class, but we still have 35 minutes. You should be able to finish it.
Page 125.
No, this is homework.
Okay? So we're going to give you guys, you have 8 minutes until lunch. We want you to get the first 5 problems at least done. And then we'll go over those answers when we come back, and then we'll let you do the rest of them. Okay, let's just do a quick check to see how well we're doing. Again, to show you the steps in order. They're very simple. I circle my variable, draw the line through the equals. I find the number with it, 3 8/10. The operation is addition, so the opposite would be subtraction. So I'm going to subtract 3 8/10 from each side. These go away. That's the whole idea of it, because I'm just left with my variable. To subtract decimals, what is my major rule?
Somebody said it over here.
Line up my decimal places. Okay, so I line up the decimal place. I can't do 3 minus 8, so I have to borrow. 13 minus 8 is 5/10. My decimal comes straight down. 3 minus 3 is 0. So x is 5/10. Our second step is our check. 5/10 plus 3 8/10 equals 4 3/10. 4 3/10 equals 4 3/10. If I've done my check, I'm good. Second one, same process. Circle my variable, draw my line. What's the opposite of adding 4 1/2? Subtracting 4 1/2. Okay, again, those have gone away, so I just have my variable. What is the rule for adding or subtracting fractions or mixed numbers? Common denominator. Okay, so we'll throw in, yeah, I don't want to go through this. So, slam dunk, we're going to multiply, then add. So, on both of them. So 3 times 5 is 15, plus 2 is 17, minus 2 times 4 is 8, plus 1 is 9. Now I need a common denominator, so I'm going to multiply this one by 2, this one by 3. That's going to give me 34 ninths, or 6, sorry, minus 27 6. 34 minus 27 is 7 6. 6 goes into 7 one whole time with 1 left over. 1 1/6. So doing our check, 1 1/6 plus 4 1/2 equals 5 2/3. To add the fractions, or mixed numbers, I can just add the fraction piece first. 1/6 plus 1/2. Do that one times 3 gets me 3 6. This one times 3, sorry. 1/6 plus 3 6 equals 4 6, which I can divide by 2 to give me 2/3. 1 plus 4 is 5. Excuse me. 5 2/3 equals 5 2/3. We have our check. Our next one, here's our variable. It's the opposite of subtracting 1/8. Adding 1/8. Again, our fraction rule, we have to have a common denominator, so multiply that by 2 to give me 6/8. 6/8 plus 1/8 gets me 7/8. Double check. 7/8 minus 1/8. 7 minus 1 is 6. I can divide that by 2 to give me 3/4. So 3/4 equals 3/4, and we have our check. Next one, here's our variable. Here's our line. What is with it? 3 4/10. Instead of subtracting, we'll do the opposite, which is add. Add 3 4/10 to both sides. These go away. 6 and 4 is 0. My decimal comes straight down. 4 and 3 is 7, plus 1 is 8. So 8 minus 3 4/10 equals 4 6/10. 8 minus 3 4/10 gets me a 6. 7 minus 3 is 4. 4 6/10 equals 4 6/10, and we have our check. Our next one, here's our x. What's the opposite of adding 2 1/4?
Subtracting 2 1/4.
I hope everybody else is following along. Again, 4 and 3 is 12, plus 2 is 14. So I have 14 fourths. 4 times 2 is 8, plus 1 is 9. 14 fourths minus 9 fourths gives us 5 fourths, which I can now turn back into a mixed number, 1 and 1/4. I have. Okay, I'm going to skip the check because I want to make sure we get enough time. How many of you did the other 5? Raise your hand if you're already done with this page. Okay, we'll give you, let's do like 4 more minutes to get as many of them done as you can. We'll correct those last 4, and then we'll go over the homework. Because we are short on time, we only have 5 minutes left, and I have 5 problems. I am not going to do a check on these because I also want to go over some of the homework pieces. But we'll at least get you the answers, okay? So here's our variable. Instead of subtracting 3 4/10, I'm going to add 3 4/10. To do that to both sides. If I do not see my decimal in a number, where is it?
At the end.
At the end, meaning I need to line it up 9 and 0/10. So that gives me 4, 12 and 4/10 equals x. Okay? 7, here's our variable. The opposite of adding or subtracting 3/7 is adding 3/7. These will go away. We have to have the same denominator. So that's going to get me 14 21st plus 9 21st, which is 23 21st, or 1 and 2 21st. Number 8. Here's our variable. Instead of subtracting 2 4/10, we're going to add 2 4/10. These are going away. Line up my decimals, gives me a 6, 2 6/10. 9, this was kind of a hard one, I apologize. Just pretty funky numbers when you work it all out. Okay, so if I'm adding, these go away.
Please.
Common denominator means I'm multiplying this one times 5, this one times 8. But we're going to turn it into improper fractions first, so that becomes 37 eighths times 5 and 58 fifths times 8. So that's going to be 35, 15, 18 over 40 plus 64, 46 over 40. Add those two together. We've got 9, 14, 649 over 40. Turning it back into a mixed number, that's going to go once. 24 is going to be 6 with 9 left over. So 16 and 9 40ths. And our last one. Here's our variable. The opposite of adding 1 3/10 is subtracting 1 3/10. Again, one of the keys being remember your decimal rules. Line up your decimal placements. 1 to minus 0 is 1. Can't do 2, so I'm going to borrow from 9 and make that a 12. Gives me a 9. 8 minus 1 is 7. 6. X equals 7 and 91/100. Any questions on any of those? Okay, turn to your homework. You can either do it in one of 2 places. I don't care which. You can do the last page of the packet, or you can do page 125 inside of your workbook if you want to keep them there. They are the same thing. So if you want to do them both, it just gives you 2 chances to make sure you get the same answer. Okay, you guys can cross out the using tape diagrams. We're not going to worry about that, at least for right now. So basically all we're saying is solve these algebraically, check your answer. Okay? Couple of notes. Number 6, number 7. Identify the mistake. In other words, there's been a mistake made. Tell us what it is. Specifically, tell us what property they did not apply correctly. And then correct the mistake and give us the actual answer. So there's 2 parts to it. On the bottom, make sure you've shown your work. All you have to do is solve for these 4 equations. The answers are over there. Just draw a line between them to show how they match up. But again, show your work on how you solve them. Any questions on your homework? So your homework is just that 1 page. Again, whether do it back page of the packet or page 125 in your modules. If you do it in your modules, make sure you're in section 4. Okay?